everyone, this is Miss Phillips coming back at you with another math lesson. Today we're going to discuss Module 4, Chapter 7, which is going to be decimals, real numbers, and proportional reasoning. Really simple. We're going to go ahead and we're going to start out with turning decimals into fractions. So for question number 1, we're given a decimal, 0.225, and we are expected to turn that into a fraction. Now there's a real simple way to turn this into a fraction, and let me go ahead get my screen right up. That way you can follow along with me. So there's a very simple way to turn this into a fraction from a decimal. And in order to do that, we are just going to turn our decimal into the number 0.225, and all we're going to do is divide that by 1,000 since there are 4 digits there. And that's our fraction. Now the fun thing about this is our fraction can be simplified. Well, right off of the bat, we'll notice that 225 and 1,000 are both divisible by 5. So you're good to go ahead, whip out your calculator. If you want to do mental math, you're more than welcome to. I'm going to go ahead and use my calculator, and we're going to do 225 divided by 5, which is 45 over. And then we'll do 1,000 divided by 5, and we'll get 200. Well, our number, our fraction, 45 over 200, is still not quite small enough. It can still be broken down. 45 and 200 are both divisible by 5 again. So we're going to go ahead and do 45 divided by 5, and we'll get the number 9 over 200 divided by 5, which will be 40. So once we get to where we're looking at our fraction, we'll notice that 9 and 40 can't be broken down anymore. The fraction 9 over 40 cannot be broken down any more than it already is. Therefore, the fraction 9 over 40 is going to be our final solution. And if you'll kind of take a look at the picture on the right, the little graph, you'll notice that there are 40 squares there, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 of our squares blanked out. This picture here just pretty much represents the overall fraction of 9 over 40. For our next problem, let me get it off of my screen right. For our next problem, we're presented with 0.036, and we need to turn that into a fraction again. So let me get my screen right back up. We have 0.036, but we've learned from past experience that we can divide this by 1,000 since there are 4 digits there. And 1,000 has 4 digits in it. So our fraction overall should be 36 over 1,000. We're going to ignore that decimal point right there. And now what we're going to do is we're basically just going to break this down even more. Well, we know, and I'm just doing a little math over here just to kind of get the juices flowing. We know that 36 over 1,000 can be broken down. They're actually both even numbers. So what we can do is we can do 36 divided by 2, where we'll get 18. And 1,000 divided by 2, where we will get the number 500. Well, these are still 2 even numbers, so we can break it down even more. 18 divided by 2 is going to be 9, and 500 divided by 2 is going to be 250. Now we can try to break this down even more if we really want to. We can We know that 9 is divisible by 3, so we can go ahead and try and divide 250 by 3. You'll notice that it doesn't really divide into it evenly. Therefore, 9 over 250 is going to be our final solution to our decimal. It's going to be our fraction that represents our decimal. And if you look at the picture to the right, this really isn't 100% accurate as far as imagery goes, but it does kind of represent the 9 over 250. We have that little bitty section that's colored in amongst a big array of just numbers and everything. So that's kind of our little representation of 9 over 250. Now for question number 2, we're going to be discussing graphs and line shapes. Again, this isn't too hard. It's very easy. We're going to start out with the equation y equals x divided by 2, or x over 2, if you'd like to say that. And really, all you need to do is just fill in x in our equation with any number you want and just graph it on the number line. So, for example, let's say we want x to be 1. Well, y equals 1 over 2. That means that y would equal 1/2. We already know our x is going to be 1. So we're just going to make the coordinates from, and we'll do this, x, y. We know when we put anything on a graph, we need to we need to use coordinates, which would be x comma y. X being this right here, and y being that right there, that axis. So we already know our x is 1, and we know our y is 1/2. So all we would need to do is, and I'll switch the color just to make it a little easier to follow along. We just go over 1, since that's our x-axis, and up halfway, since that's our y-axis. Make that a better y. Yep. So our point would be right here where our arrow is. Again, we can do the same thing. Let's say we want our x to be 2. Well, y equals 2 over 2. And another way to say 2 over 2 would be the number 1. Well, we know our x is 2. We know our y is 1. So when we go to graph our solution, we're going to go over 2, up 1, and that'll be our point. And if we just keep going and going and going, eventually we'll get this big long line that kind of represents our numbers and how our line will be shaped. Now we're going to move on to our next equation, which is y equals negative x divided by 2. Very simple, again. Let's say we want to start out with 1. Y equals negative 1 divided by 2. Our 1's automatically going to be turned into a negative. And I'm going to write this right here so we have a little example, our x to y. This is our y-axis. This is our x-axis. Our 1 automatically gets turned into a negative 1. And from then on, we can just solve. Negative 1 divided by 2 is just going to be negative 1/2. Well, we already know that our x is 1, because that's what we put on our blank. And our y is going to be negative 1/2. So now, what we're going to do to graph that, we're going to go over 1 for our x and down halfway for our y, and that will be our point. Again, let's say we wanted to do a negative number instead of a positive. Let's say we wanted to do negative 1. Well, y equals negative 1 divided by 2. And since we have two negatives here, those will cancel each other out, and we will be left with a positive 1 divided by 2, or 1/2. So when we go to find our coordinates to graph, we can simply put -1 for our x, since that's what our input was, and 1/2 for our y, since that was our solution for our y. Now we're just going to graph that. We're going to go back 1, up halfway, and that'll be our point right there. Again, we're going to move on to our next equation, which will be y equals 10x. Well, we know, let me change my color. We'll do orange this time. I think orange is an exciting color. We know y equals 10x. All we're really going to do, we're going to substitute x for any number that we want, really. So let's say y equals 10 to the 1. All right. Well, now what we're going to do is we're just going to do 10 times 1, which will be 10, and that will be our y. And we're going to do our example, x comma y. That's going to tell us which one goes on the y-axis and which one goes on the x-axis. We are going to put our 1, since that was our input, that was our x, and our solution, or y, which was 10. And now when we go to graph this, we're going to go over 1 for our x, up 10, and this is on, I guess I should say this now before I go to forget. This graph right here is going to be in increments of 2. That way we can fit everything together, just because it's a little bit harder to fit a big graph like the one we're needing on here. So one tick right here would be 2. Another one would be 2. So 2, 4, 6, 8, 10. It's going to be the same going up. It's going to be 2, 4, 6, 8, 10. And now all we're going to do is go over 1 for our x, go up 10 for our y, and that will be our point. And again, if we do the same thing, let's say we wanted to do -1 instead, we could do y equals 10 to the -1, which will be -10. You can use your phone, your calculator, mental math, anything you want, you'll get -10. Our input, or our x, was -1. Our y, or our solution, would be -10. And that's what we're going to graph on our graph. So we're going to go over -1. We're going to go down -10, and that will be our point right there. And that's just going to make our line. Now again, we're going to move on to our next equation, and this one's a little bit funky. It's not a straight line like our others were. Whoops, let me get that back up. It's not a straight line like our others were. It's actually pretty curved. And this is because, if I can get it back up, this is because our x is being squared. So let's say, and you'll kind of see what I mean. Let's say we wanted to make our x a 2. Well, y equals 2 squared. You can do this mental math, do it in your calculator. 2 squared is pretty much going to be 2 times 2, which is going to be 4. And let's do that right there. So we have that, our y, our x. We know that our input, or our x, was 2. We know that our solution, or our y, was 4. Now we're going to go over 2. Let me use my red. Over 2, up 4, and that will be our spot. That will be our point on our graph. Again, let's say I wanted to do -2 instead. And this is where things get interesting, because any negative number squared is going to be a negative times a negative. And when you multiply a negative by itself, it cancels out the negative and becomes a positive. And you'll see what I mean. So like 9, or y equals negative 2 squared, negative 2 squared. Well, we know that negative 2 squared is going to be negative 2 times negative 2. And since we're multiplying two negatives right here, they're going to cancel out. They will no longer be there. They will be gone into the abyss. Use a little red on that. That way we know it. And since our negatives are canceled out, our problem's going to turn into 2 times 2. And 2 times 2 is going to be 4. So now we're going to make our point. We know our x was negative 2, our input. We know that our solution, or our y, was 4. So now in order to graph this, we're going to go back 2, 1, 2, up 4, 1, 2, 3, 4, and that will be our point. And I know my arrow isn't too accurate. It's actually a little funky at the moment, but that will be our point. And eventually, once we graph enough numbers, we will get, let me erase this, we will get a line that makes a big U shape like this. And that's what happens when you square a number. When you square your x, if you have a negative, it turns into a positive. If you have a positive, it stays positive. Therefore, nothing will ever go below this line right here, our x-axis, and this side will always be blank. Now we're going to move on to our next problem, which is going to discuss fractions. It's actually pretty simple. It looks a little complicated just because we have stuff everywhere, but actually, in all reality, it's really, really not too bad. So for our first problem, we're given this image right here. We have a small red triangle that's sectioned out of our big square, and we need to find out what our fraction is for the problem. Now, what I like to do personally, we already know that our square is split into 4 equal sections. We have 1, 2, 3, and 4 if you put these two triangles together. So now what I'd like to do is we already know we have one of our sections split in half, and half of that is shaded. So all we're going to do is split our other sections in half to match, just like that. And now we have a total of 1, 2, 3, 4, 5, 6, 7, 8 sections. We have a total of 8 sections. So now all we really need to do is create our fraction. And our fraction is actually going to be very simple to create because we know that one of our square triangles are shaded out of our 8 sections. Therefore, our fraction would be 1/8. Again, we're going to try this method on another one. This one looks a little complicated. It's really not. It's pretty simple, actually. So all we're going to do, I'm going to use black this time to kind of follow along. We have, and this is ignoring our triangle, we have 1 square, 2, 3, 4, 5, 6, 7, 8, 9 squares all together. Well, if you'll notice, one of our squares is split in half. So why don't we make the rest of our squares match? So we are going to do, let me flip that back. We're going to do that, 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 that. 1, 2, 3. And now everything matches. Every single bit of this square is split into equal parts. It's into even parts. Everything is the same size. Now all we need to do is figure out what parts are shaded and how many we have altogether. Well, we know we have 2 triangles per square, so we're going to do 2, 4, 6, 8, 10, 12, 14, 16, 18. We know that we have 18 sections altogether of our square once we got done splitting it all into equal parts. Now, as far as our shaded parts go, we have 1, 2, 3, 4, 5, 6, 7 altogether, which means that we are 7/18 of our square is going to be shaded. Again, we're going to try this on one more. We have a circle. This one's actually split in equal parts. It's really very simple. We don't have to split it anymore. And the reason why, once I get my pen up, the reason why is because this right here and this right here are the exact same shape and size. So all we need to do is find out how many parts or sections, equal sections of our circle are there, and then how many are shaded. So we have one section of our circle shaded, and altogether we have 2 sections because 1, 2. So when we go to create a fraction for our circle, we'll notice that half of our circle is going to be shaded. Now moving on, we're just going to discuss patterns and area. This one can be a little complicated sometimes. I know I was thrown off when I first went through it. It's pretty simple if you just kind of get the general shapes. Imagine once you get the general idea of how things go. So for our problem, we are given a hexagon, and we're asked to figure out how much area each shape takes up in our hexagon. So starting out, we're gonna work on our triangle, I believe. And if you'll notice with your triangle, if you put it up here, that takes up 1/6. And what we can do, we'll do our screen right real quick just to have an example. We have 1, we have 2, and 3. Our hexagon is split into 6 equal sections, and our shaded area, or our triangle, is taking up one of those sections. So our triangle is going to be 1/6 of our hexagon. Another way to say this, we know that our triangle is 1/6. So what we can do, let me get this pulled up, my calculator. We're going to get the number 100. 100, put it in your calculators. This is another step, or another way to find out what the percentage is, going from fractions to percentages. We're going to put the number 100 in our calculator, and we're going to divide it by 6. All right. And once we get our solution, which is 16.666666 discontinued, we are going to multiply that by 1, our number 1. And our solution should be, once we've rounded it up a decimal to the nearest hundredth, should be 16.67, which means that our triangle is going to be this first one right here, 16.67. So now that we know our triangle is going to be 16.67, let me get that off of there, put that back. Actually, we may get rid of this right here just so that we can move stuff around. I'm going to go ahead and type in 1/6. That didn't work out too well. Let's flip our triangle around. We're going to put 16.67%. And we're good. Slight technical difficulties. Next, we're going to test out our rhombus right here. we'll notice that our rhombus, and it's not exact, it's not the exact shape, but it does do the job when you're teaching. Let's imagine our rhombus takes up a third of our hexagon, and the way we can kind of tell would be to split our hexagon into 3 equal parts, like that. And then we have 1, 2, 3 equal parts. One of our sections are shaded, so it will be 1/3 of our hexagon. Another way to figure out the solution would be to do 100 divided by 3. 100 divided by 3, which is going to be 33.33. Well, when we multiply 33 by 1, our solution is going to be 33.3, which means that our rhombus is going to take up 33.3% of our hexagon. Now again, let me get that off of there. We know that this takes up 33.33%, so we're just going to type in 33. Ooh, my shapes are everywhere. 0.3%. So now we know what area that one takes up. Next, if you'll notice our hexagon right here, whenever we go to put it, or I mean not our hexagon, our rhombus, when we go to put it on our hexagon like that, we'll notice that it takes up about half of our shape. And the way we know that it takes up half of our shape is because when we go to split it into equal parts like this, 1 out of the 2 sections of our hexagon is shaded. Therefore, 1/2 of it is shaded. And in order to turn our fraction into a decimal, we're just going to divide 100 by 2, and we should get the number 50. We'll multiply 50 by 1, which we already know anything multiplied by 1 is going to be the same number. So 50 is going to be, 50% of our hexagon is shaded. And what we're going to do is move our hexagon down here. We're going to put 50%. Now, last but not least, we have the percentages for our rhombus, we have the percentage for our trapezoid, and for our triangle. Now we need to find the percentage for our square. And since we have just about everything else, we have 33.3, 16.7, and 50%, we can determine that 38.5% of our hexagon will be taken over by our square. So what we're going to do is put 38.5%, and we're going to fix that because apparently my shapes want to be strange today, and that will be the solution for our problem. Now for our next set of problems, we're going to be discussing percentages, parts, and wholes. Very simple stuff. It's actually pretty much talking about certain amounts of a total. Just basically what we've been going over so far. So for example, for question number 5, we're given the problem, Jamie has 4 gold stars. She gives her friend Alexandria 2 of them. What percentage of her gold stars did Jamie give away? Well, Jamie has 4. She gives away 2 to her friend Alexandria. And this will be Alexandria over here. We'll give her some hair, maybe a smiley face. Alexandria has 2 gold stars now that Jamie gave away. Well, a way to set up, to figure out what percentage or how much, what fraction of her gold stars Jamie gave away, we're just going to put, or draw, I should say, we're going to draw a picture that kind of helps us determine it real quick. We'll use yellow just to be, oh no, we'll use orange to make it a little bit easier. We know that Jamie gave away 2 of her gold stars, and forgive me, these aren't very good gold stars, and altogether she had 4. So we're going to put the total number of how many gold stars she gave away on top and how many she had in the beginning at the bottom. Well, once we look at our picture, we'll notice that we have 2 gold stars up top. We have 4 gold stars for our total at the bottom. And we eventually get this fraction of 2 over 4. Well, this fraction can be broken down. Both of the numbers are even. They're both divisible by 2. So what we're going to do is divide each one by 2, and we should get 1/2. Now, when we look at this 1/2, we should know that this 1/2 represents the total number of gold stars, or the total amount of gold stars that Jamie gave away to her friend Alexandria. And if we really want to push it and find out what the percentage altogether is of the gold stars that Jamie gave away, all we really need to do is, we have our 1/2. We are simply going to divide 100 by 2. By 2, we should get the number 50. We know anything times 1 is going to be that number. Well, 50 times 1 is 50. So 50%, or 1/2 of Jamie's gold stars, were given to Alexandria. Now for our next problem, we're asked, we're asked, Jamie has 4 gold stars. Alexandria asks for 25% of them. How many gold stars did Jamie give away? Well, 25% of 100, 25%, let me go ahead and do that. When we write 25%, we're basing that out of a total number of units of 100. So when we write our fraction, we're simply going to do 25 over 100. And now we need to simplify that. Well, both of these numbers are divisible by 5. So when we go to divide 25 by 5, we get 5. And 100 by 5, we get 50. These numbers are still divisible by 5, so we can go ahead and break that down a little more. And we should get a total solution of 1/5. Not 1/5. 25 divided by 5 is 5. 100 divided by 5 is going to be 20, not 50. Excuse me. We're getting there. It's going to be 5 over 20. Both of these numbers are still divisible by 5. So 5 divided by 5 is 5. 20 divided by 5 is 4. Our ending fraction is 1/4, which means that Alexandria took 1/4 of Jamie's gold stars. Well, we have 4 stars right here. If Alexandria took 1/4 of her gold stars, she took 1 out of the 4 stars, which means one of these went to Miss Alexandria right over here with the pretty flowing hair and the pretty smile. So now Jamie has 3 gold stars and Alexandria has 1. For our next problem, we're asked, Jamie gave away 75% of her gold stars. Alexandria received 3 gold stars. How many gold stars did Jamie have to begin with? Well, if Alexandria has 3 gold stars and Jamie gave away 75%, that must mean 75% of Jamie's gold stars is 3. 1, 2, 3. We know that in order to find out what fraction of Jamie's gold stars were given away, we need to figure out our 75%. Well, 75 over 100 is going to be, because we're making this into a decimal now, or a fraction, I mean, just so that we can kind of get an idea of how many gold stars Alexandria has compared to how many gold stars there were altogether that Jamie had. So 75 divided by, or over 100, well, we know that both of these numbers are divisible by 5. 75 divided by 5 is 15. 15. And 100 divided by 5 is 20. Again, these two numbers are still divisible by 5. So we know that 15 divided by 5 is 3, and 20 divided by 5 is 4. Which means, and we'll go ahead and circle this because this fraction is a really huge part of finding our solution. Once we get the general fraction down, the simplified fraction down, we'll notice that 3 of those stars were Alexandria's. And on the bottom, we'll notice that 4 was the total number of stars that Jamie had to begin with. Alexandria got 75% of Jamie's stars, or 3/4 of her stars, which means that Jamie started out with 1, 2, 3, 4 gold stars. So red right now, but 4 gold stars. Now for our last problem, our final problem, take a deep breath. It's almost over. We're going to be discussing proportional reasoning. And I know it sounds a little tricky. It's actually pretty easy. For my problem right here, we're going to be discussing a cookie recipe. Yummy cookies. For our problem, we're pretty much told that we have a cookie recipe. We need to make enough for 20 people, but our recipe only makes enough for 4. So what do? How do we make our recipe, or how do we alter our recipe to where one batch makes enough for 20 people instead of 4? We know our recipe right here makes enough for 4 people. We want to make enough for 20. So what is 20 divided by 4? How many batches would we need to make of our cookie recipe in order to get to 20? Well, we know that 20 divided by 4 is going to be 5. And since we know that we need to make 5 batches in order to serve 20 people, all we need to do is multiply the amount of each recipe right here by 5. And then we'll have enough of each thing, of each product, to make enough for 20 people. So for example, 2 cups of flour, the 2 cups of flour that we need, we're just going to multiply that by 5, 2 times 5. And now we need 10 cups of flour in order to serve 20 people. Again, 1 teaspoon, multiplied by 5, 1 times 5, not divided, will be 5. So we need 5 teaspoons. Again, 1 times 5 equals 5. So we'll need 5 more teaspoons of salt. 2 multiplied by 5 will give us 10. So we need 10 eggs. And 1 times 5 is 5. So we need 1 teaspoon of vanilla. And this is pretty much our same cookie recipe, just bumped up a little bit, altered a little bit, so that we can serve 20 people with one serving of our cookies. We'll only need to cook 1 batch of cookies instead of making 5 batches of 4 to serve all of our guests. And that's it for today's video. I hope y'all had a good time. I know I did. And I'll see you in the next one.